So you're going to get a bag with your stuff in it, and it's got your last name on it. So make sure you only take one with your last name on it. In the bag you'll find a green board. This one's green on both sides, there's not a blue side. So you got to be careful and make sure you are putting the things in the right side. The side that has the words on it, that's the up side. And then the components will go on the top where the words are. On the bottom where the little shiny places are for soldering, that's where the wires stick out. Okay? There are directions. There's like a little thing here that tells you where everything goes. There's a parts list that tells you what everything is. And then there's also this is called a schematic diagram, which is what an electrical engineer type person would create to show you how this circuit is put together electrically, how everything's connected with the right symbols. It's a little bit beyond what we're accomplishing right now. All right. So let's just start at the top of the board and take a look at what we're going to put on there. At the top of the board, we have LEDs. So we have two LEDs, and an LED is a light emitting diode. So we already had our introduction to diodes, and we learned that a diode is a little device that lets let me get rid of this thing. Gosh, I sure wish I could get rid of this thing. I guess I can move it down. Is that big enough for people to see? I could zoom it in. Good? Alright, so a diode, what is the symbol for a diode? A diode symbol is this, and it's basically the little electrical hieroglyphics for something that only lets things go one way. And if we put a bubble around it and have light coming off of it, then it would be a light emitting diode. And so basically the way light emitting diodes work is you have that diode material in there, which is the N type of semiconductor next to a P type of semiconductor. And remember, these are like silicon or whatever semi-metal they're using, and they dope them with different impurities, like arsenic is one, and it makes them either positive or negative. So anyways, when the electricity flows the right way through the light-emitting diode, it excites the electrons and kicks them up into a higher orbital, which would be something you would learn about in chemistry if you take that. And then when the electrons drop back down into their regular energy levels, a light is given off. This is the same technology we used in the Navy to measure our radiation exposure with the dosimeter. The light was kicked off, right, and dropped back down, and they measured how much radiation we got. So the light-emitting diodes go on the top. Notice that on the circuit board, there's a flat side. It's important to put the light-emitting diodes in the right way. They have a right way. So if you look on the diode carefully, the diode has a flat side, but it's really hard to see it. Make sure the flat side of the diode matches the flat side on the circuit board like this. If you put it in upside down, it's not going to work. Alright. Next, we have some resistors. And we already know what resistors are. There are two types of resistor. We have some 470 ohm resistors, and we have some 220,000 ohm resistors. So these are vastly different in their resistances. They are completely not interchangeable. The quarter watt just refers to how big the resistor is and how much power it can take before it melts. So these are pretty small. These are for small, low energy, low flow, low current applications. These little tiny resistors, unlike the ones that we may have used in the labs, we had the big giant. I buy the big giant resistors on purpose to prevent you from melting them. So we have two different kinds. You got to use the color code. So use your color code calculator that's in your toolbox to make sure you have the right one. Right? We have resistor 1, resistor 3, resistor 4, resistor 2. If you don't put the resistors in the right places, the circuit won't work. The resistors don't care which way they go. They can go in either way, so they don't have an upside down or a right side up like LEDs do. LEDs have a right side up and an upside down. No upside down. In between the resistors, we have a place for capacitors. Capacitors are pretty little clever, very simple items, but basically they store electrical energy. These little guys here are the capacitors. They look like little water towers, round little cylinders. Some capacitors don't care about being upside down or right side up, but these ones do. So some capacitors do. If you look really careful at this, you'll see it has a white stripe. The white stripe is the negative side. The white stripe is negative. If you put the capacitor in upside down, why don't you go ahead and talk to your partner? Guess what's going to happen? No, it's not going to blow up. It's just not going to work. They don't blow up. It's a 9-volt battery. So make sure the white stripe goes down on the negative side. Below that, we have transistors. And these are these little deals here with the look like a half moon. Transistors basically are electrical switches, and they're basically based on diode or semiconductor technology. Instead of having two pieces of semiconductors stuck together, we have three. And this is a 3-port device, so it has 3 legs. And it definitely matters which way it goes, but this one's easy. The picture on the green plate has a flat side, but it's very easy to see what the flat side of the capacitor is. It's really hard to actually put these in wrong. All right, just make sure the 3 legs go in, and the flat side is on the flat side. And there's a lot of other things that I could tell you about transistors, but it's not that kind of a lecture where we dig deep into the weeds. Just know that these 2 things are going to act like little electrical switches. This is the part that makes the blinkers take turns blinking. Blink, 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 blink. So if you have a blinker where the lights are just coming on and not blinking, it's probably an issue and there's something wrong. There's something wrong with your soldering on the transistors. All right, below that, you know what? I forgot to write down the word transistors. All right, and they look like this. And they have 3 legs. The capacitors look like this, and they have 2 legs with a negative side and a positive side. The resistors have stripe patterns. They don't care. And light emitting diodes are probably everybody knows about light emitting diodes. It's pretty common stuff. Down here we have a switch. It's a 3-prong switch. It's got on and off. It's an on-off switch. So there's a switch. Switches don't care. There's not an upside down for this switch. You just pick one way or the other and it'll work both ways. Sometimes the switches are hard to get into these green boards. This one feels like it's going in pretty easy. But sometimes they can be kind of stubborn. So just be gentle with them. And then the last thing is switch, is a power snap. The power snap looks like this. And they go in here where it says plus minus. Red is positive. Black is negative. This is where you're going to hook up the 9-volt battery to see if it works. You don't get to keep the 9-volt batteries. You have to buy your own 9-volt battery for when you take it home. All right, so that's what all the pieces parts are. Once you've done a great job of soldering it all together, so let me just put all these things back in this bag for this person so I don't lose them. Oh, one more thing about these. Sometimes these power snaps, the wires are exposed and you can just solder them right on. But sometimes they're not. So you're going to have to use your yellow-handled strippers to gently strip a little bit of wire off in order to expose some of the wire to solder your power snap on. So I'll give this guy one where the wire's exposed. I'm nice today. Here's what I would do. Solder everything on one at a time, top to bottom, or bottom to top, so that the things that you soldered on aren't in your way, and then test it. And then if it works, then trim the legs. You can have a bunch of pokey legs sticking out of your circuit board, and that's not what you want to take home, because they'll touch each other and short each other out and poke you, and it looks weird. Don't trim them, because if it doesn't work, you're going to want to take some pieces out and turn them upside down or replace them or something. It's much harder to work with components after you've trimmed the legs off. So you don't want to do that. You want to trim the legs off after you know that it works. Well, that wasn't too bad for note taking. I'm going to turn off the camera now.